welcome to this presentation on data collection field to finish. How sharp is your field pencil? My name is Ladd Nelson. I am the Midwest Regional Sales Director for Carlson Software. Basically, today we're going to talk about concepts related to the types of things that a field surveyor can do to help automate the process of how to collect data efficiently and use that information in the office environment to make digital maps that are both effective and efficient for making content that is relevant for today's digital world. Essentially, when you're out in the field, think of a GPS receiver, a prism on a prism pole, essentially as a pencil. When out gathering data then, you can use this digital pencil or plotter pen, if you will, as a tool to create those maps in a way that you can bring that data into the office and make use of it readily with the computer systems that are very quick to build that data in a way that you don't have to spend time connecting the dots. Those days are old and over. So as we think about ourselves as virtual pens or plotters, if you will, all we have to do is think about how would I draw this as if I were drawing it in the office, but think of it while we're doing that in the field. So as I move about my project site then, if I just take a little bit of forethought and move about efficiently and effectively, I can make, like I said, maps that are very easy to make use of the technology tools that technology providers provide. So to get started here, I have a lot of material to cover, and we're going to be talking about feature code libraries and special codes. And on this particular project site we'll be talking about here today, I gathered some data in actually different datums, NAD83 and UTM, and we're going to be actually producing data in a low distortion projection system here in a little bit. We're going to talk a little bit about Windows versus Windows Mobile, for example. Look at some NGS control marks, the spacing of datum, how to make uniform spacing. Talk a little bit about national CAD standards. Looking at the location where data can be placed and how you can shoot up and control multiple lines with one particular shot to help control the placement of break lines so you don't get crossing break lines when you make surface models. Editing and processing of raw data to produce the coordinate files, and then all this data is available online. So with that, we have a lot of material to cover. So as you think about, again, working out in the field, a lot of times people tend to get lazy and they think, well, I'll just connect it in the office. And again, why go through and do the work twice? So with that, as I was meeting with some surveyors in Wisconsin here, actually a bit ago, there was a nice open park in Dane County, Wisconsin. And it looked like it was a nice project area because it had a nice long roadway entrance that I thought would be a good training example for some roadway projects. It had some parking lot areas and some islands for good grading examples. It also has a nice published GPS control area location, and it's also the location for where the Madison area surveyors have their typical summer picnic. So the overall project is comprised of two main parts. The road project, which I shot using state plane Wisconsin South coordinates. And in the southern area, I shot using UTM coordinates. And the main purpose for this was to illustrate the fact that I could utilize different coordinate projection systems, but then bring all that data together, or amalgamate it, if you will, into a low distortion projection system. And in Wisconsin, for example, they use county-based coordinate systems. And as a lot of the states moved into regional-based or LDPs, or low distortion projection systems, we can take the raw data from the field and then morph that data together and make it usable into one specific coordinate system. So let's begin. As we're working through this particular site, one of the things that I wanted to do was collect it efficiently. And as I started with the entrance road in shot number 101 up in the northwest corner, I decided to code that with an edge of asphalt 0 code. And one of the things that I decided to do with this was utilize the Wisconsin DOT feature code library. And as I traveled along the edge of asphalt for the road that services the county park, I picked up point number 102, and I decided to code that shot with an edge of asphalt 0, and then a space. And then I decided that it was, at that point, it was coincident with the edge of asphalt 2, and I decided to use that rather than edge of asphalt 1 because I wanted to try and keep it consistent with, I thought, which I was going to try to be clever, to use evens and east and odds and west and that kind of stuff. But as I was going southerly into my project site, I was just trying to be clever and realized that I didn't have to have my lines ordered in a particular way. So anyways, I decided to call my westerly line edge of asphalt 2, and that was also where its point of curvature began. So I said, this is where at point number 102 here, that I have edge of asphalt 0 and edge of asphalt 2's point of curvature is beginning. I continued down the road to point 103, where it was edge of asphalt 0, and where center line 1 of the service road that serves the park begins. And I continue on to point 104, where edge of asphalt 0 and the edge of asphalt 1's point of curvature was, and then continued on to point 105's edge of asphalt shot. That's about all I really wanted for the edge of asphalt for the main highway that's outside of the project site area. And then I came around and said, okay, now let's start moving ahead into the project site area, and picked up edge of point number 106 for edge of asphalt, which is a point on curve. And then I picked up point number 107 for the center line 1 shot, and then point 108 for edge of asphalt 2, again a point on curve. And then I came down into the project site area for point number 109, which is edge of asphalt 2, and point 110 for center line 1, and then point 111 for edge of asphalt 1. Now, I did a little bit of a faux pas here in that I did not specifically put a PT code on points 109 and 111. I should have. That would have been a very smart thing to do, because if I would have had a multi-point curve in there, I could have said exactly where those point of tangency locations should have been. Carlson Serve PC, for example, in this case, which is what was used, is smart enough to know that if I don't explicitly put a PT code on those shots, it will infer from the PCs placed earlier that we have a 3-point arc, and that's how this was drawn. So in this case, I then moved into the grassy areas, and I picked up a stop sign, point number 112, and then moved into some grass shots and filled in sort of the areas for making surface models in this area. So I picked up points 113 through 116 over to 117, down and around, and then sort of sparsed it out with the remaining grass shots in and around. And there's also some signage shots in there, points number 121 and 122. And just sort of filled out that little entryway area. Now, based on my point numbers in here, and again, I continued on for my road, and I just cross-sectioned back and forth, picking up the edge of asphalt, the center lines, and also the shoulders as I was going through, following the same convention, basically every 25 feet along this entire length of road. And one of the things that this is sort of a hindsight kind of thing, was that might have been too close of a spacing for this little county park. I mean, I spent a lot of time doing every 25 feet, and probably in hindsight, maybe 50 feet would have probably been a little bit better. And the other thing that was sort of a little bit of a problem spot, but this was sort of the hand I was dealt, which was the DOT codes that were in use are typically a lot of 4 character types of codes. The edge of asphalts were sort of nice because they were 2 characters, which is what I usually like to use. But a lot of their codes were 4 and sometimes 5 characters long, which was a lot of typing in their code list. And because I was not typically familiar with their code list, I spent a lot of time going through their hundreds of codes looking for the one that was most familiar to me. So that sort of slowed my process down. So with that, let's talk about how we actually got into the particular project. So again, sort of my notes in here, the takeaways is that number 102 and 104 were dual coded. That defined the PC. Shot number 103 was also dual coded. So that helps control the placement of dual polylines for brake line considerations. And that we're going to do the roadway cross-section pattern was in effect. And like I said, unless explicitly provided, that ServPC would assume that the third shot to be a PT for a 3-point arc, and then it is filled in those grassy areas with that random intent to make a pleasing looking surface model. Okay, so to begin, what I did was then I created a brand new job inside of ServPC. And as I was getting started, one of the things that as I was walking to the project site, I just said, all right, well, I noticed that there was actually a GPS control point actually on the within the park itself. I'll talk about that in just a moment. So I came in and I said, I want to set up a new projection, coordinate projection type. So I'm going to go in and edit my projection list and add a predefined projection and change and just choose that I wanted to change off of the normally NAT83, excuse me, and go into the USA Wisconsin County Coordinate Systems and chose the Dane County Coordinate System. This is one of the LDPs, and hit green check when I'm done. So I'm going to add in, for using both UTM and Dane County Coordinate Systems, these are some of the favorites that I'm going to use for my work area. Some other things I'd like to set when I'm inside of the software, and this is usually just a one-time setup, is that I like to make sure that I timestamp each point. So not only do I know where I am on a project site, I know when I am. So that if there was any kind of problems with almanac information, ephemeris information, anything like that, I can go through and look at my raw data to know that, again, if there's a problem spot in my data, that I can look at that raw data, look at its timestamp and say, okay, these are the potential problems, problem spot shots that I can come back and not have to resurvey the entire site, as an example. So here is the base station location, and one of the things that, as I was looking at here, nice little paved area here, nice wide open area. So this is the area where I decided to set up my particular base station. So I decided in this particular example not to use a cellular network. So I was going to set up my base and put it on a known control location. So with this, I'm going to go through and we can just choose any particular desired manufacturer that we happen to work with, whether it's Topcon or Leica or Spectra or anything like that. And in this case, I was using the Carlson BRX6 Plus receiver. And from there, I'm just going to go and click on my Communications tab and indicate how I want to communicate with that particular receiver. We indicate the receiver height above ground, which I had measured up, and then indicate the fact that I want to utilize the internal UHF radio and utilize the RTCM 3.2 communication message type. Once I'm ready with that, I'm going to go ahead and hit green check, and then I'm going to indicate that I have the latitude and longitude for that known benchmark. So as I was, again, out there looking around, there was a placard for Ron Ripp, who was the Dane County surveyor up through 2004, and very nice dedication to his memory. And the approximate latitude and longitude was placed there, but more precise information was actually put out onto the NGS marker location. So I went out and fetched that information from the NGS website and then placed that into ServPC. So since NGS was providing me the elevation information in meters in here, I went through and pushed that information in and designated with the M met, metric designator that I went through and said, okay, I want to place that information in, and with a green check, it will convert it over into feet for me. And that was the location that I was assigning to my base location. And also decided to store that location into my project. And again, this is in the control file, so that's okay. And I'm going to go ahead and say, yes, my base station is successful. Continue, save these settings into a file. I'm going to say yes to this so that I can, if I ever need to come back and set up my base again, I can just reuse this information and not set it up again and have to punch all that information back in. So now with the control job established, we're actually going to move into an actual job. In this case, we're going to just follow the same kind of procedure. Now we're going to create a brand new road job. So now with the road job, I'm going to go ahead and edit my projection list, and this time I'm going to use the Wisconsin South. And again, the Wisconsin South was specified thinking that if I was a DOT person, maybe I'd want to be utilizing the information for their typical use, which might be for state plane kinds of systems. So again, I'm going to go ahead and this time I'm going to say, yep, I want in my Wisconsin South project, I'm going to use the control file for the a reference location, for example. So I'm just going to go ahead and green check on that. And as I go through, maybe I've had set up, maybe somebody had gone out and originally had set up using Wisconsin South, but now I'm out here later on getting ready to go out and actually do my work. So control had maybe been set up a week or two ago. Now I'm going to come back and use this. So I can either say I'm setting up my base now a couple days later, and I want to use from either a previously surveyed point, or I can read from file. And again, this allows the use of that reference file, that base reference file we just created here just a moment ago. So in 1 day's worth of operation, I don't actually have to do this, but if I had come back at some previous days later, a couple days later, then this would be the way I would do this. So again, we don't normally need to do this. This is just being shown for illustration. I would go ahead from the from point. You can see up at the top part of the screen here, I would choose that I'm picking my point from the control file at this point, and I just green check. And we can then say that we're using point number 1 from the control file, and we can go ahead and put that control point into my road job if I want to, and we do not need to save the base configuration right now because we've already got it saved. Okay, so we're in the survey road job, v-road, and for my road job name here, I'm following sort of the CAD standard configuration for my file name convention for the roadway project. And again, we're going to set the rover now. So I go into my GPS rover option and choose again the brand and make and model of the rover that I'm working with. Again, also this was a BRX6 receiver, and they're going to go ahead and choose that we're going to be pairing up with this via Windows Mobile, and indicate the height of the receiver, and also 2-meter pole height in this case, utilizing a UHF radio. And the option is if you were to wanting to be used on the Wisconsin network or our RTK network, you can utilize that as well. So just for those in the audience who do want to see how the end trip settings are set up, I'll just go ahead and show that real quick. You can change over to the RTK tab, set your device to data collector internet. It is very typical. You would choose that you want to, back up here. I'll just take a look and say for the end trip, which is the next line down, you would choose the wrenches to the right of end trip. I've got one network here, which is very popular in the upper Midwest, which is the HPRTK network, and you would just indicate the IP address and port, your username and password for those credentials. and then the name of the bases that you want to use for that particular network. And then once you've gone ahead and selected that, you can connect up to the network, and typically before you get too far from your or into your project site, you want to make sure that you actually have a fixed solution. So for that, I usually go into the equipment tab, go into monitor SkyPlot, check for fixed solutions, and make sure that yes, in fact, you do have a fixed solution. So now that we've got a fixed solution, we'll also take a look at some of the configuration settings. So underneath the equipment tab for button number 5 for configure, we're going to go ahead and take a look at some things that I like to do. So typically when you're coming in, you will want to go into the, as you're new to the software, for example, want a prompt for height and description. And typically also like to use a coding style of either the classic or the one-touch store points option. So the other thing we'll do in here now is we'll also look at some of the acceptable tolerances so that you can mitigate some of the errant shots that you might otherwise get. So if we're going to go ahead and take a look at this, we might say the minimum solution type is fixed. So if the receiver happens to get into an area where multipath or obstructions cause your solution to degrade, or if a network happens to falter, or if you get too far from a base and the radio solution happens to go into or produce a float solution, for example, you can indicate a minimum solution type to be fixed only. You can also indicate specific PDOP tolerances, proximity radius and incline tolerances for receivers that support that kind of setting. And other receivers that are out there might also give you what's often is known as a sure fix solution. So you can check with your brand of equipment and choose what kind of positional tolerances you're going to be comfortable with. And in the event that the receiver is not producing the results that are at or better than these tolerances, you'll be at least flagged about whether or not you want to store the point before continuing. So with that, now we're going to take a look at the list of codes that we might want to work with, which are the features that are going to be drawn with in this case, our GPS pencil. So as we're going through, I started off with my edge of asphalt code. So I had an EA code, for example, and I used EA for both edge of asphalt 0, 1, and 2, but I have a single EA code. So I don't have to have an EA 0, I don't have to have an EA 1, I don't have to have an EA 2, just have a single EA code, which helps control the symbology for that code when it comes into my map screen, which we'll talk about later on. And in this case, as I was traveling along, I also ran into a culvert that ran underneath the road, so I created a culvert code. And as I take a look in here, I'm going to place that culvert shot on a V for survey storm underground layer. And for the storm or the culvert type of shot, I want this to be drawn with a 2D polyline. Now some people might say, well, why not a 3D polyline? Aren't culverts 3D in nature? Well, yes, they are, but they're not surface entities. So I want the points to be drawn at elevation, potentially for surface modeling considerations, but I don't want their flow lines to be designated for surface model considerations. We have more capabilities for that inside of the Office software, which we'll talk about in a little bit. So in this case, for the map screen, we want these to be drawn as 2D polylines only. As I was working through the project site then, here's sort of a summary list of all the different codes that I used on this particular project site, and then their National CAD standard layers that I specified. And you're free to make changes to these as you want. And then also the entity type that I chose. Now in this case, the Wisconsin DOT code library does not conform necessarily to the National CAD standards, but I believe that we as a profession ought to be moving towards something that is sort of uniform. Now I know everybody's not always in favor of having a CAD standard, but imagine the world if all of a sudden, we all said, yeah, we can get on board with this. We can make sense of this. But in 30 years, when these drawings are all be passed around and all these things are organized and layered in such a way that they all sort of make sense, to me, I think that makes sense to the people that will follow on our footsteps to understand what this data means and what it contains. So with that, here's more of the library and what it looks like then inside of the ServPC. And we started to build in then the line types, entity types, and the layer names that we have. Also down below in the lower right-hand corner, we had some special codes. And the other thing I did make some changes in here was I decided to match up ServPC's begin and end line codes to match up with the Office software so that as I choose to start and stop lines, I can have those codes match up with whatever my Office software is, whether it's Civil 3D or Bentley MicroStation, anything like that. So now we again get into the data gathering process. So we go into the Survey tab and choose the Store Points. And then sort of a reminder in here what we did. So starting up at point number 101 up in the northwest corner, moving along and starting into that crisscross pattern throughout the length of the road. And again, as I was working through my project site, I started in my store points, and I had to make sure that I went into point number 101, put in the description of VA0, clicked on the little store points button up in the upper right-hand corner, and if I needed to make some configuration changes, I can make that change down the lower right, which is the wrenches icon. And as I keep moving through, I can just keep pressing enter on the collector or the little store points on the screen, and it'll just keep storing that point. And as I keep moving through here, I can choose whether or not I want to have it prompt for the height and description for me, which we'll see here in the next screen. So I can turn that option on and off. As I get more familiar, I might know my code list in advance, and as I get familiar with my code library, I might be quicker for me just to type it in rather than it is to pick it off of the being prompted for it. So here's an example of being prompted for the notes and the heights and all that kind of information. So within the storing of points, I can choose the type of code. So in here, I got some buttons that show my centerline code, control point code, edge of asphalt code, grass code, and I would actually need to change my grass code. I don't need line work on my grass shots. That was one little error I had in my code library. I have to go back and fix that. Same thing with the sign code. So a little indicator there showing the line, which is something I need to go back and fix. And the option in here makes it possible then for me to go through and tap those buttons and simply change the description very easily with the tap of a button in this library. The special code buttons over on the right-hand side give me the ability to put the begin, end line codes, which are the green and the red line with arrows on them. Also the PCs and PTs if I want to close up building footprints or mirror rectangular corners of a building, indicate lines, segments, and there's actually more options in here. So quite a bit of information is available when you're being prompted for height and description. So again, we moved through the data set in here, continued into the road, and now we, as I got through to the collection of all my road data, then I got to this area where I said, okay, now it was getting late in the day, so I decided to come back the next day and pick up my site information. So as I was coming into the site, this is the area where the GPS marker was stationed, my base station, and also where I have a lot of the parking lot areas, parking islands, and some of the building structures and sidewalks and things like that. And I decided to collect this up with UTM coordinates. I decided to do this with county GIS concepts in mind. And again, the precept behind this was to utilize these two different data sets for client training purposes. And I decided to gather this data with a completely different data range, point number range in mind. And one of the things that, as I was looking at this little project area in here, was how to code the paint stripes and the perimeter of the GPS paving area, paver area, so that all these lines and the edge of asphalt, so that all that line were collected and connected correctly. So as I came along the edge of asphalt at point number 1187, and I coded that up with edge of asphalt 2 and pavement marking 1, which is a paint stripe. Then I decided to move over to shot number 1188, and that was edge of asphalt 2 and pavement marking 2. And then I went to 1189, which is edge of asphalt 2, pavement marking number 3 now, and where stone 1 begins. And I kept on moving along where the along the edge of asphalt to 1190, where I have edge of asphalt 2, pavement marking 4 began, stone number 1 continues, and then 1191, where edge of asphalt 2, pavement marking 5 began, and stone number 1 continues. And I jumped down to 1193, where pavement marking number 1 took a corner or a bend, and then jumped down or next to 1194, where pavement marking number 1 continued and pavement marking number 2 ended. And then 1195, where pavement marking number 1 continued and pavement marking number 3 ended, and then just continued on. And then as I traveled along, I got to shot number 1198 and coded that one with edge of asphalt 2, pavement marking number 1, stone number 1, and then looped around all the pavement, the stone codes, and got to eventually around to point number 1212, where I said stone 1 close, and that closed that figure back onto the edge of asphalt. And then from there I continued on with the edge of asphalt to the finish out the parking lot. So that was a very complex set of coding work. And here's more of the information in a little bit bigger detail. So you can see that this was a very roundabout lot of material in here. And the one new improvement that we made in the software since this data was originally gathered was up and around the 1209, 1210, and 1211, was we put an arc fit algorithm into the routine to help take that kink out of the PC and the PT areas in there. So if you wanted to use the AFIT point code in there, that'll help smooth out that little jog that I put in there. But that was also sort of tough to see because a lot of that had been grown under by some planting growth that was in that area. So I was going to go through then and re-access the job menu inside of ServPC now to get into my site project. So I'm sort of doing this out of order here just a little bit for you. But I created a brand new site project. And again, I wanted to go ahead and utilize the UTM coordinate system zone. And again, I used my control project and put in some brand new codes. In this case, one of the stone codes for the stone pavers, if you will. And I had these 2D polylines, excuse me. And here's all the different codes that I used for my site project, and also the layers and the entity types for those. And again, same kind of setup as the day one. I went through, set up my base, same kind of configuration settings. So I'll just sort of quickly flip through these real quick, and all the same setup as from before, but this was all done on day 2. So it came also same thing. Set up my receiver, back to store points, and the other area that I had a lot of work and detail work, which was on one of the parking lot islands in here. So we have a raised grass mound parking island, which was also abutting a number of parking lot stripes. And here's 2 pages worth of paint stripes that you'll see. And point number 1115 is one that is the edge of asphalt 4 closing with, or closes up edge of asphalt 4, and also has pavement marking number 62. And here's page number 2, and you can see also on this there was also some deciduous trees and also some grass shots that I threw in there. So when this all is said and done, you can see in here that I had this to look forward to. So quite a busy data set out there, and lots of information going on. And you can see again with all the trees on the islands and the paint stripes and the GPS control area. And then I also put some gridded topo shots out there just to sort of surround it a little bit. Quite a bit of material that was going on. So here it is now with the some of that information now cleaned up a little bit so you can sort of better see what was going on. And this is all being done in the map screen of ServPC. Now, for use in other applications, such as Civil 3D, for example, or Bentley Microstation for that matter, you can go into the map screen and choose File and then export, whether you want to export a DXF or DWG. You can take this content right out to other applications and make use of that there. The data that you've gathered can also then be sent out to a land XML file, and you can take your coordinate file out to that land XML file for use in other applications. And if you want to, you can also go back to the File tab inside of ServPC, and you can choose the Export option, and you can export out an ASCII file and choose even to a KML or KMZ file, and send it out to an online application such as Google Earth or ArcGIS Earth from Esri. So that completed in this case, about the day and a half worth of data gathering for this whole area. And what I want to do now is to bring it all together, and we're going to do that inside of the desktop office software. So now what we desire in this case is Wisconsin's county-based coordinate system, in this case for Dane County. We're going to use information inside of our draw field to finish routine, and we're going to make an existing ground surface model. We're going to validate this Google Earth, and optionally, if we have some means, we're going to try and integrate with LiDAR data, maybe as a optional tool set if that option information is available. So to begin, we're going to launch into Carlson with its shortcut desktop shortcut, excuse me. So to begin then, what I want to do is a new project. And I want to create a brand new drawing, and we'll click on Next. And in this case, I do actually have a National CAD Standards survey template drawing that ships with the software. That has all of the National CAD Standards layering conventions that are pre-furnished for me. And in this case, what I want to do is I'm going to change into the desired coordinate system. So I want to change my projection. So I'm going to click on the Define Projection button, add predefined, change it off of my list from the USA from at A3 and go into the Wisconsin Whiskers, what's called the Whiskers County Coordinate System, and choose Dane County. Now, as a other states adopt low distortion projection systems. You can find your state systems here, or you can even add it from file. So if you take a look back at the previous one, you can even say add from file, and you can go load up an Esri PRJ file, for example. And that way that you have all sorts of flexibility in terms of what your projection information will look like. So I've added the Dane County projection in one of my favorites. And I continue into the system then, and I've got this set up in here as my one of my favorites now. And I've got my drawing set as my V-Proj drawing. So that's going to be my project drawing. And again, I use my layering name convention as sort of my file naming convention, just helps keep things simple. And I validate my path, the coordinate file name that I want to produce, and we'll just click on next. And what I want to do now is make sure my survey menus are loaded, in this case, for my desktop CAD software. And I'm going to go into the survey menu of Carlson, choose the edit process raw data routine. And what I want to do here now is bring in the raw file that has been gathered out in the field. So again, I might have raw files from a number of different data sources, whether again, and I've truncated the list here just, but I can bring it in from TopCon, Trimble, Leica, Carlson, obviously, and assemble this raw data into one overall massive data set. So I'm going to go ahead and bring in the road data set in here. So I'm going to go ahead and open that up. And here's the preliminary information on the road raw file. And as we take a look at this now, I'm going to go ahead and then do that exact same operation on the site data set. And I'm going to go ahead and open up its file, and then also instruct that the raw file editor should look at the control file that I had also established, and specify the control file here as specified earlier. And now, before we continue, I'm just going to go ahead and take a look at some process settings. And as we look at that, I'm going to indicate that as we process, should we draw the points in the line work by field to finish prompt or not? So in here, what I could probably do is say, yeah, I should prompt me. I'll just indicate that here in the side of the software. But once I'm ready, I'll just go into the process compute points command and say process GPS. And once I'm ready, I'll indicate that I do want to process this into the Dane County coordinate system. And if I have a different geoid that I want to apply for elevation factor values, I can do that. And one of the options that I do like down there is the checkbox to create point notes, and just click on OK. So we will then get a coordinate list of all the different coordinates as assembled from both days worth of data in this case. And then I can exit from the editor. Do I want to save the raw file change? And in this case, it's up to you. You can save the raw file. In this case, I didn't start from a raw file, so I could either say yes and create a brand new composite raw file of both of them. But if I had opened up an individual raw file to start editing it and then brought a new one into it, I might want to say no to this. So it's up to you. You want to be careful with this. Do I want to save the coordinate file changes? Yes. So I'm going to create a brand new coordinate file, but now I'm going to go ahead and say survey draw field to finish. Point number 102 had that edge of asphalt 0 and edge of asphalt 2, which is a multiple code. Let's go ahead and split those up. And we're going to go ahead then and start to look at this information. And before we do that, we do want to take a look at our codes. And here's all the codes now with the layering conventions that we brought in. And we'll take a look at the codes via the code table settings button on the left-hand side of the screen. And we can see in here that We could actually bring these in from a number of different sources, whether it's, again, Trimble, Land Desktop, Civil 3D, Tapcon. So we can bring these codes in and look at the lower left-hand corner for my special codes. This is where we'd want to match up the codes that are used in the field versus what we want to use inside of the office. So once we're done with that, we're going to click on the OK button and then click on the OK button. And now we're going to be at an area where we can actually say, let's go ahead and place this information into CAD. And then we'll issue the View Extents command to see it on screen. And then there's our completed composite amalgamated map. So now we've got that. And what we want to do now is, since this is sort of oriented more north-south, let's better rotate it to better fit our screen. We're going to go to the View menu. And we're going to say, let's go to the twist screen by surveyor method, and we're going to choose the 180 azimuth to make that do east-west. And we're going to go ahead and say OK, and now that's been oriented on the screen. Let's reprocess it one more time to set the latitude or the attributes to those are done. And now this has been set up here in a black to sort of show the points and how these things are located on the screen a little bit better. And once this is done, now we can go ahead and triangulate and contour to make our contour map. So with this, we're going to go ahead and write the information out to a surface model triangulation file. And we'll review the contour tab here in a minute. So we're going to create an existing tin. We do want to shrink wrap the perimeters so we don't have to create a boundary around the data set. We want to ignore zero elevations. We like to minimize flat triangles. And also we will go ahead and write this information out to, again, layers that are V topo minor and V topo major, again, sort of following those national CAD standards. And again, those layers are already preset for us in this template drawing. And for the labels, these are some of the settings that I like inside of the software. And again, for the labels, I like to put those on the same layer of the contours themselves. And we're going to go ahead then and just choose next. And we're going to select all our entities. And if I happen to get any errors, in this case, I've picked up just a few, but they were off by about 3-4 thousandths. So probably not enough really to worry about in this case. So I'm just going to sort of skip over those errors. And if I want to, then I can just apply some annotations on these, start to label some berries and distances, put my title blocks, bar scales, north arrows, that kind of stuff, and I'm pretty much ready to go. So with that, I'm going to go through and freeze some other content off of here, and then export out to Google Earth just to validate all this information is where it needs to be. And I'm going to go out to export in Google Earth and indicate what it is that I want to select and how I want to see it. So we're just going to go ahead and choose OK. Indicate that I want to create a Google Earth friendly KMZ file called v-proj. And we'll hit OK, and again, create this with all the data that I have left on my screen. And there's the result. And again, people might ask, well, why is this data not lined up right with Google? Well, if you turn on the historical imagery slider button up in Google and start to roll back, you can see that the data here is just fine. The imagery is going to change over the course of time. So I would be trusting the data better than I would trust Google Earth imagery. So in conclusion, I would say with a little bit of practice and forethought, you can use your field pencil, your electric pencil, if you will, to collect this data in a way that makes it efficient and easy to make your maps usable in the office with precision and efficiency. So you, as a surveyor, are an artist and efficient and not having to reduplicate work. So with that, I'd like to say that it's just a little bit of time and effort to understand it's all in the feature coding and the special codes. They can dramatically simplify the office work. One shot can control multiple lines. Take a look at, in this case for Wisconsin, the DOT and their code library. consult with your state's or local government for their particular code library. Look at the national CAD standards. They can help. Also, the NGS control that was used is out there and published, and proper spacing is also great for making good-looking contours and surface models. For the Windows mobile world, you might want to look at regular Windows, because Windows mobile world is starting to fade away, I think. And today's rugged PC tablets really do have a lot of horsepower over the traditional handheld sets. And when it comes to different project data configuration sets, it really doesn't matter. We can handle it all. So with that, I would like to say thank you for your time. If you have any questions, feel free to give me a call. Have a great day.